What's up, guys? It's your boy Davidcito, and this is Leetcode 3432. Count partitions with even sum difference. So yeah, you have a array of numbers with length n, and yeah, your partition is just going to be your left subarray, including these indices, right? So it's gonna have index 0, 1 all the way to I, and then I plus 1, I plus 2 all the way to n minus 1. And yeah, that's the definition they give. Make sure that your I is always less than n minus 1 just for this definition to work and stuff. And yeah, so I'm going to talk about my implementation real quick. Oh, I forgot one thing. So yeah, you want to return the number of partitions where the difference between the sum of the left and the right subarrays of your partition is even. So yeah, I actually used the whiteboard earlier. So basically there's a test array, right? There's a test array right here, and this is going to be my prefix array, right? The reason why I wrote out this prefix array is, I'm gonna be completely honest, I kept trying to like compute it on the fly and I kept messing it up. This is like my third take, but yeah, you know, you have your prefix array, and what you do is you literally just loop through every single index. First, you compute this prefix array, which is like O of n, I think. Oh, wait, no, I know it's O of n, right? But then you loop through every index and you create a partition. So your first partition at I equals 0, right? And then to see if this is even, right? If your difference of your left subarray and right subarray is even, it's very simple. It's just taking your prefix sum, right? Because notice that this prefix sum already computes the left part of the subarray due to construction. So yeah, this left part is going to have 3, and then this right part is going to have, well, it's obviously going to be the sum of all this array minus the sum of the left side of the partition. So it's going to be 43 minus 3, and it's going to be 40, right? So it's going to be 37, and no, 37 mod 2 is equal to 1. So yeah, this isn't going to be, this partition isn't an even partition, right? And so what you do is you go through the whole array, right? And you just compute it that way, and you should get your answer. But there's a much better way to do this that they discussed in the editorial. But here, I'm gonna show my code real quick. There's the prefix sum implementation, and this is the editorial implementation. I'm just gonna scroll down a little bit. And so yeah, this is their implementation. Basically, they just realized, okay, we can just calculate the total sum. And if your total sum is even, you're for sure going to have at least n minus 1 valid partitions. Otherwise, you're gonna have 0. And why is that? You know, you might ask, why is that? To show this, I'm actually going to just start off on a new drawing. So I'm going to erase everything real quick. Simple. And then what I'm going to do is I'm going to just do like this. Right, you got your array with n elements. I'm gonna denote them as follows: A1, A2, A3, blah 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 blah, all the way to here. Wait, let me just do this like that, all the way to AN, right? So this is your array, and so basically, I'm just gonna create a partition right here, or let me do in the middle dot just to denote that, like a very arbitrary partition. So, you know, this is your left side and this is your right side, right? So, note this. Your left side is always going to be equal to even, or it's not, it's going to be equal to L. I'm just going to denote it as L, and this is R, right? So the relationship between L and R is that L plus R is equal to your total array sum, right? Your total array sum, right? Sorry. And then there. So L plus R is your total array sum, but you go through each case, right? So suppose that you have uh one of your L is even, right? So let L equal 2k, right? And then here's what you're gonna do. Check the case for total equal 2k, right? Or no, wait. First establish that your total is even, right? So case total is equal to even. Oh shoot, my mouse. Okay, there. Sensor was bugging, but case total even, right? And so what you're gonna have is you're gonna have t is equal to 2k. So you can have two cases, right? To get an even number, you can either have okay, L is equal to 2k plus 1, right? L is odd. And R is odd. Right? Because notice when you add these two together, you're going to get, you're going to get an even number because this just becomes a 2 and you know that this is going to be even, right? So overall, you're going to get an even number. You can test it with a bunch of numbers, right? Or you can have L is equal to 2k and L is equal to 2k, right? And you're going to have, these shouldn't be k, this should be j. Or I'm just going to denote it M and M because the k's don't have to be they don't have to be the same, right? 2n plus 1, R is 2n plus 1, right? So you can have this or you can have this. 2m and R is equal to 2n. So you can have these two cases. And so essentially, when you subtract these, you're always going to get an even number, right? Then note the following. You can subtract any single, right? It's always going to be this way because of the total. You can test it yourself, but this is true for all the partitions. Now notice if t is equal to 2k plus 1, you're going to have something different. L has to be equal to 2k, and R is 2k plus, or 2m. Oh man, guys, I'm sorry. Okay, 2m, R is 2n plus 1. Or you're going to have that L is equal to 2n plus 1 and R is equal to 2n, right? Now you subtract these and you realize you're always going to have this 1 left over. 2n minus 2n is going to be an even number because 2n minus 2n is going to be 2 times m. Oh shoot, my handwriting. 2m minus n, right? So whatever is to the right here is always going to be, like, it's still gonna be there. This is gonna affect if your number is even or odd, right? Because this is 1, your number is going to be odd. So notice that regardless of the case, when your total is odd, no matter what, your subarray, like every single partition, when you subtract the right and the left subarray, is going to stay odd because these left and right subarrays, this by algebra, just by algebra, bro. That's it. But yeah, you can test it for a bunch of arrays and you'll see that this holds true. So yeah, that's why they just did it like this and it worked. But yeah, oh shoot, and this guy has a 1-line solution, so good on you. Here, I'm gonna just upvote that. That's aura right there. But thank you for watching, and yeah, just keep doing your Leetcode and stuff, and bye.